Okay, so we've seen that we've used the if statement to check what the user's input and make a decision based on that. But there's a bit of redundancy in that previous example, because we've asked the user for two for an operation, either plus or minus. If they've typed in plus, then we do one thing. If they haven't, then assuming they haven't done something wrong, they must have typed in minus. So we don't need this extra statement to check whether the operation is minus. We know, assuming the user's got has done the right thing, then we can just assume that this is going to be minus. So either they type in plus or they type in minus. If it's not plus, it must be minus. And so we don't need to check whether the operation is minus. Instead, we can use what's called an else statement, or strictly speaking, an else clause. It's not a statement because it can't stand on its own, but let's call everything a statement for now. And the way that works is like this. So we have a if condition is true, then we do these statements, and else, if the condition is not true, then we do these statements. So it's either or, either this or that. And that's what we want for our calculator. We don't want to allow any other possibilities, either plus or minus. There's no other possibilities that we're allowing for. And that's the else statement. You'll notice, just like the if, it's got a colon at the end of it, and the statements after it are all indented to tell you and Python which statements will get executed when either the condition is true, it will be these ones at the top, or if the condition is not true, it'll be these ones at the bottom. So that gives us an either or choice. Okay, and the else must accompany an if statement. You can't put an else in a program on its own because Python won't know what you're talking about. So our new version of the code then looks like this. It's got, we ask the user for the operation. If the operation is plus, then we add the things together, and if it's minus, then we subtract them. Okay, let's just run that one. There's the code. 4, 2. If I put in minus, it will subtract one from the other because it looked to see whether that operation was plus. It's not plus, so it must do the subtraction. Okay. What if the user doesn't type plus or minus though? Let's try it. What would happen? Think about it. So let's put in 5 and 3. Suppose the user wants us to multiply them, and then they're just going to guess, so they put a star. It does a subtraction again. Okay, so that is although I think the program is better because we got rid of that redundancy of checking whether the operation is minus, there's a problem because now if they put in anything other than plus, it's going to subtract the two numbers. Okay, so it's always subtraction if it's not a plus, if they don't put in a plus sign. Okay, and this brings up a little idea of defensive programming. That there's a problem in that last program in that it makes the assumption that if the user doesn't type in plus, they must have typed in minus, and that's wildly optimistic. It's wildly optimistic to assume that users will never do something wrong. Users will always do something you don't expect. So you've got to try and cope for all of those things, and we'll see how to deal with that a bit later on. Nonetheless, it's so we've got two versions of the program now. One is kind of contains redundancy, so we're checking something that we don't need to check, but the other version is risky, and we'll see how to improve on both of those things shortly. Okay, I'm going to finish that video here. The next one is about the elif statement. So it allows us to have more choices. So what if there's lots of different things that could happen? It's not just plus or minus. What if it's plus or minus or times or divide? How do we deal with that?